We are finishing up chapter 7, Techmath 1. We're out of the blue book, but actually we're going to be looking at the packet right now. And so with the packet, we're going to do this basic terminology, interior angles, exterior angles. You can read through that. That's just a little bit of reading. Perpendicular means two lines intersecting to make a 90-degree angle, right? And adjacent means they have a common side. All right. So those are not really any big new things. Parts of a degree, you might not know that. So when we're talking about degrees, we'll do degrees, minutes, and seconds. And it's just like our regular minutes and seconds, like just what you would think. There are 60 seconds in a minute. There are 60 minutes in a degree. So it's just like our time, but instead of hours at the end, it's degrees at the end. So here, let me explain a problem. Let's look on the packet. On the bottom, it says E4, so the fourth page in, and number 11, where they want us to add 42 degrees, 0 minutes, 19 seconds. Okay, so oops, that's a degree sign. And 9 degrees, 0 minutes, 24 seconds. So it's a little confusing because like how we make feet and inches, that's what we do for minutes and seconds. All right, so addition. So let's do the addition. So when we add this up, check this out. This is what? 13, carry the 1, and then 43 seconds. That's still 0 minutes, and then 51 degrees. So 51 degrees, 0 minutes, 43 seconds. All right. Okay, let's take a look at part B. 6 degrees, 18 minutes, 12 seconds, and 104 degrees, 9 minutes. So if we were adding those together, this is 0 minutes then, so that's 12, or 0 seconds, 12 seconds. That's 27 minutes. That's 110 degrees. So 110 degrees, 27 minutes, 12 seconds. Let's say I want to convert this into just all degrees. Well, think about what that would be. That would be 110 degrees plus. To make this into degrees, we'd say 27 divided by 60, because there's 60 degrees in 1 minute. And now that would be degrees. And if we wanted to jump from seconds all the way to degrees, let's think about this. How many seconds are there in an hour? There are 60 seconds in a minute, 60 minutes in an hour. So 60 times 60, 3,600 seconds in an hour, right? So if I want to convert this all the way from seconds all the way to degrees, not to minutes and then to degrees, I go 12 divided by 3,600. And so this is what it looks like in degrees, minutes, seconds. This is going to be just all in degrees. So if I did that, 27 60ths is 0.45, and 12 3600ths is 0.0033333333 forever, and 110 still is 110. So we would have 110.45333333 forever. This is the same as 110 degrees, 27 minutes, 12 seconds. All right. Now, I don't think you're going to actually do any conversions like this. You're just going to have to add them and subtract them. And so it does get a little trickier because you can't have numbers bigger than 60, right? If you went to a movie and it was 85 minutes, you usually don't say 85 minutes. You say like 1 hour, right? And then take 60 subtracted from 85 and say 25. So 1 hour and 25 minutes would be the length of the movie if it was 85 minutes. Same thing with degrees, minutes, and seconds. If it goes above, you have to carry it over to the next thing. So take a look at number 12 on the bottom of E5. It's 16 degrees, 43 minutes, 24 seconds, and 42 degrees, 57 minutes, and 18 seconds. So now we have to go from smallest to largest, because now watch. This is 12, carry the 1, 3, 4. So that doesn't carry, we're good. That's 42 seconds. This one is 10, carry the 1, that's 5, and 5 is 100. Well, it can't be 100 minutes. So you're going to take and subtract 60 from it and say 40 minutes. And what that 60 does that I took out of the 100 becomes 1 degree. We carry it up to there. All right. And now that's 7, 8, 9, and 5. So 59 degrees, 40 minutes, 42 seconds. All right. And here, let me show you B. 9 degrees, 32 minutes, 50 seconds, and 28 degrees, 49 minutes, 24 seconds. So again, if we add, we go from the smallest to the largest. So 474. Nope, no can do, because that's bigger than 60. If it's bigger than 60, you have to subtract it off. 14 and, right, 14 seconds, but that adds 1 minute to the mix. So now 49, 9, 10, 11, 12, carry the 1. That's 82. Nope, that's not okay either. 82 minutes, that's bigger than 60. So we have to subtract the 60 off. And that gets you 22 minutes, and then you add 1 degree up there. And then that's 10 and 28 is 38. So 38 degrees, 22 minutes, 14 seconds. All right. There is a way to do it on the calculator. I'll show you really, well, it isn't really quick. I think it's actually more work to do it on the calculator than it's worth, is my 2 cents on that. Let's say we want to do the 9 degrees, 32 minutes, 50 seconds. So you go 9, and then where is that under? Nope. Oh, angle. Burp, dirt. Okay. So we go 9, and then we do second. And then the apps button right there, it says angle on yellow. So we're hitting the yellow. And now look, it has degrees and minutes. So do the degrees, and now look, it says 9 degrees. And then 32, you do second, angle. And so don't go down 1, and that's minutes. So 9 degrees, 32 minutes. And then now for seconds, that's a little trickier. You do the 50. So we write the 50 in there. And now seconds, if you take a look on the plus, it's under the alpha. So not the yellow button, but the green button, the alpha button, and then the plus, and then it throws the second sign up there, all right? Now we have to do the same thing. We gotta go plus, and then do 28, second angle, degrees, and then 49, second angle, minutes, and then 24 alpha plus, and that threw the seconds on there, and then enter. And now look, it says 38 point, blah, 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 blah. That's all of the degrees, minutes, and seconds in decimal, but don't worry, one more entry here. You just hit second angle, and then see number 4 is degrees, minutes, seconds, DMS. Hit enter, and then enter. And then there's our answer, 38, 22, 14. I think it's easier just to do it on paper and carry, subtract off the 60s and just carry 1 over. But I've had some students that say, nope, they love the technology. They'd rather type in all of that stuff rather than doing it the other way. All right. So let's take a look at 13. So degrees, minutes, and seconds subtraction, but not just subtraction where we have to actually borrow. So this is a slight bit more complicated, and that might be worth the effort to type it into your calculator with degrees, minutes, and seconds. Make the calculator do it. I don't know. You can decide. Let's take a look at 13. That is 74 degrees, 18 minutes, 21 seconds, 10 degrees, 30 minutes, 30 seconds. So, but we're subtracting. So when we subtract, look at what we have to do. This, I have to take away from there, the seconds, but I don't have enough seconds here. So I'm gonna borrow one of the minutes, make that a 17, and then that adds 60 to that number. So 60 plus 21 is 81. So we took a minute away and that added 60 seconds to it. Now we can subtract it. Now 81 minus 30 is 51 seconds. Now look, I left that with 17, but that's not enough either. 17 and I'm trying to take away 30. So I'm gonna kill that 74, make it a 73. I'm borrowing a degree, which adds 60 minutes onto that 17 minutes. And we get 77 minutes. And now 77 minutes minus 30 is 47 minutes. And then the last one is just 63 degrees. So 63 degrees, 47 minutes, 51 seconds. Let's do one more. So that was letter A. Let's do letter B. 43 degrees, 0 minutes, 6 seconds. 20 degrees, 14 minutes, 37 seconds. So, oh no, look at what happens. We have to borrow from here, but there's nothing there. So we gotta go one more down. So this becomes a 42 degrees. This becomes a 60 minutes, but not for long. I'm gonna cancel that and make it 59 minutes, and then that adds 60 seconds onto the 6 seconds, 66 seconds. And now we subtract 37. Geez, they really made this one tough. So 5, what is that? 8, 9, and 29 seconds. Now, at least we don't have to borrow for this one because we already borrowed already. So 45 minutes and 22 degrees. All right, 22 degrees, 45 minutes, 29 seconds. So some students are like, yeah, that's worth it, pumping that into the calculator and hitting all those buttons. So you can decide. All right, and then the last thing on this handout, I want you to skip to the three-dimensional graphing, and you can look at the first couple of pages, F2, F3. They do a pretty good job of explaining it. I want to jump in where it gets a little more difficult, like let's take a look at just a couple of problems here. Go to F5 and we'll take a look at that. So three-dimensional drawing is a little tough to get your head around because it's on a two-dimensional surface. And so we have to have it look like it's 3D. And again, I've had some students that are just very intuitive and very good at doing this. I am not very inclined for 3 dimensions. So we've got 3 coordinate planes, and this is also weird because the one coming out at you, that's the X. The one going this way, that's the Y. And the one going up and down, that's the Z. And so what I do, because I'm very not inclined, let me show you what I do. I draw a box. So look, this is X, Y, Z. And it's always going to be the corner of the box farthest from the origin. So look, this is the origin right here. And so X is 1, that comes out 1. So I'm filling in that one really dark right there. Y goes 5, so 1, 2, 3, 4, 5, that's there. But now look at what I have. I've got this box. Like a little rectangular box, it's like coming out. Kind of at ya. And then 3 up, well, that's this. And so now if I draw that out where the 1 was, and I connect that, and if I draw this out where that was, and I draw that part, and I draw that part, and there we go. And so the point is actually, the 3-dimensional point on the picture is right here. So now look, if I follow it like a pattern, X was 1, so I went out here 1. Y was 5, so I went to the right. From that point, from here, I turned a hard right and went over 5 spots that way. And then from that corner, I went 3 up. And there I am. Now, I've had students that say, why do you need all that box and everything? You just go 1, and then 5, and then 3, and I just put a dot right there, and it's perfect. And that's fine. If you can do it perfect like that, go for it. I'm going to draw a box every time. And so, here, 4, 1, and 2. I'll do that one in red on the same thing. So you can kind of see. So 4, 1, and 2. X, Y, and Z again. This is point T. So 4 from here, from the origin, 1, 2, 3, 4 is this. Okay? 1 on Y is just 1 away from there. So that's right there. 1 on Y is like that. And then 2 up is right there. So then you draw right there, you connect that, you draw that again, and there it is. So if I go 4 forward, 1 to the right, and 2 up, there's my point. Okie dokie. So that is 3-dimensional graphing. It's always kitty corner. Look, if this was a box, it would be kitty corner, the outside top corner each time from the origin. All right. That's a little tough to get the hang of, but once you try it a couple of times, it's not that bad. So, and take a look. They have the little pictures. They don't draw the full-on box usually. They'll just draw things, but they've got the key for those on the end. So take a look at what they've drawn too. All right. Awesome possum.